Now you may have seen degree measure before, but now as we start to go and looking at a different trig, we're going to bring up a radian measure. So what we know about angles and what we've already seen is typically an angle that's made up of two rays. So how we're going to make it different now with a radian is we're going to eventually start working with a unit circle. So we're going to have an initial side and a terminal side. Now these are going to fit on what we call our unit circle, where that x-axis in the positive direction is going to be our initial, and the terminal is going to be the other side as it goes out, whatever direction it may go. So let's say it goes out in this direction. There's our terminal side. So this is our angle that we're looking at. It's the angle formed there. Now we could have done that with degrees too, but we also have this is the positive direction. So that's counterclockwise will always be a positive. Pull a positive there. And when we go in this direction, it will be a negative. So let's think of a couple examples of that before we go on. So let's say I have an initial and a terminal side right here, and that's 90 degrees. 90 degrees in the positive direction. Now if I went in this direction, I went negative, we need to write that in degrees. Now, positive and this negative, if we think all the way around the circle, is 360, so we actually went negative 270 degrees to get to that point. So we could call this either a 90 degree or a negative 270 degree, and it would mean the same thing. Now most of the time we're just going to state it in the positive. This we should know is 180 degrees. It's also going to be negative 180 degrees. Now let's think a little bit further. What if I went all the way around the circle and then halfway again? So I went 360. This turns out to be 540 degrees. It starts at that initial, it goes all the way around, and ends at the same terminal. So it's still the same value, but we'd also say, well, that could also be 180 degrees or negative 180 degrees, and we're going to see there's some other options as we go through that. So what if I was out here and this was 150 degrees? Now 150 degrees combined to some value is going to give us the 360, and that value is 210, but that's in the negative, so we'd call that negative 210 degrees. So hopefully you're starting to see some examples to that. Now let's think radian measure. So this is our new one. We're not talking about degrees now, we're talking about a radian measure. And we have this rule here that theta equals S over R. S is going to stand for the arc length, R is the radius, and theta is the angle measure. So as we draw this unit circle here, we have an angle that's formed. We have a radius, and then we have this distance, which is the arc length out there. Now that's going to help us to start to see it. But before we get to that, let's start to see that there's some patterns that exist. So we know that 2 pi is all the way around the circle. And this is given to us in the definition for a radian. We also know all the way around the circle is 360 degrees. So let's start to break it apart. Well, if 2 pi and 360 are equal, that means pi is equal to 180. So I just divided both by 2. And I could go further and I'd say, well, pi over 2 is equal to 90 degrees. Pi over 3 is equal to 60 degrees. Pi over 6 is equal to 30 degrees. Pi over 4 is equal to 45 degrees, and we start to see some common ones that are showing up. And these are ones we actually start to use throughout the unit circle. So we know here is pi over 2, pi over 4, pi over 6, pi over 3. Now if I came down here, that would be pi plus another 90, or pi over 2, and become 3 pi over 2. So as we start to convert, we see some automatic ones. These you'll come to memorize with no problem. But then there's some that may not be as obvious. Well, let's say if we started with radians. So what if I now had 9 pi over 4? Where would that go? Well, I know I start here at 0 or 2 pi. Well, 9 pi over 4. So I know this is 4, because it's 4 pi over 4. This would be 8 pi over 4. So this actually goes around the circle more than 2 pi, because I know this because it's greater than 2 pi. So how could I simplify it down? So, well, similar to what we did earlier, I could subtract 2 pi away from that to give me a better value. Now, this exists on the unit circle, and I can find a radian. We just want to write it in its simplest positive form. So I'm going to subtract 2 pi from this, because really by adding or subtracting, when I go around 2 pi, it doesn't change the value. That's going to be 8 pi over 4, because that's 2 pi over 4 written with the common denominator, with the 4. So this leaves me with pi over 4. So that means to get to 9 pi over 4, I went all the way around and stopped here at pi over 4. It's the same value. What if I had negative 7 pi over 6? So I went in this direction to that. I want to figure out what that is. Well, I can write its coterminal angle, an angle that's going to be positive to it. I'm going to do that by saying plus 2 pi. I can write it with common denominator, so that's going to be 12 pi over 6. Gives me 5 pi over 6. Now, we haven't really labeled that one yet, so let's think where 5 pi over 6 is. Now, 6 pi over 6 is pi. So I am 1 pi over 6, one slice of pi over 6 short of that. So that would be right here. Now, to convert from not common values, or really any values from degrees to radians, we're going to use this formula right here, which is degrees times pi equals 180 times radians. And degrees is the value we get in degrees, or radians is the value we get in radians. And typically it's going to be they give you a value in one of these and you have to solve for the other. So what we can do is isolate either of those to get the formula that we need. So the degrees is going to be equal to 180 over pi times the radians, meaning if they give us a value in radians, it's, for example, 2 radians, and we want to find that in degrees, we're going to plug that value in radians into this to get our degree result. Now, the ways we can remember that, typically radians come in values like pi over 4, pi over 3, or 4 pi. By dividing by pi here, we're actually getting rid of that pi, multiplying by 180, which is going to convert it to degrees. So that's one of them we want to use. The other one is if we're going to get radians by itself. And so that's going to give us radians equals pi over 180 times degrees. So for this one, we're going to get a degree value. We need to convert it to radians. So with the same thought we had up here, where we have to get rid of that pi, when we go from degrees to radians, we almost want to bring in that pi, because typically that's how we write values for radians. Now, you may come across an example where they just give you a whole number for radians, and then that doesn't quite fit. But it's just paying attention to that rule that you're going to use. So these are the two that we have. So let's look at an example. Let's say I have 60 degrees. If I had 60 degrees, I'm going to plug that in to this rule, the second one, and that's going to give me pi over 180 times 60, which is 60 pi over 180. I can reduce 60 and 180, and that becomes pi over 3. Maybe we have 320 degrees. I'm going to do pi over 180 times 320 degrees. I get 320 pi over 180. I can reduce, and I get 16 pi over 9. Now we look at one more. How about 230 degrees? For 230 degrees, we're going to do pi over 180 times 230. Gives me 230 over 180 pi, which becomes 23 pi over 18. Now, let's take a look at converting from radians to degrees. Let's say we had pi over 6. For pi over 6, we're going to go back to this first rule, which is 180 over pi. The pi's become 1. I'm left with 180 over 6, which is 30 degrees. If I had 5 pi over 3 in radians, and I want to find that in degrees, I'm going to multiply by 180 over pi. The pi's become 1. I have 3 and 180, which becomes 60. So I get 5 times 60 is 300 degrees. What if we had 3 radians? So for this, I'm going to still do 180 over pi. It's just not that common one where we have a pi to divide out, and it actually becomes 540 over pi, which we could then approximate by plugging in and get a decimal representation from it. The last thing we can attach to this is arc length, because earlier on we had that theta equals s over r, or the measure of the angle is equal to the arc length divided by the radius. If we rearrange this by multiplying r to both sides, we get that the arc length is equal to theta, the measure of the angle, times the radius. And this is the formula we're going to use for arc length. So let's say we had a scenario where the radius was 15 inches and the measure of the angle was 120 degrees. If we wanted to find the arc length of that, we want to change that to radians. So to change from degrees to radians, it's going to be pi over 180 times 120, which comes out to be 2 pi over 3. So I'm going to say 2 pi over 3 times 15 gives me 30 pi over 3, which is 10 pi inches. We could do another one. Maybe this time we know that the arc length is 42 inches and the radius is 14 inches. We can now find the angle that would occur in that scenario. So that's going to be 42 equals theta times 14, which becomes 3 equals theta. Now, this is one we have to be aware of. This is 3 radians. If we wanted to find out what that would be in degrees, we'd have to convert that. So that's going to be 3 times 180 divided by pi, which gives us that 540 over pi, which comes out to be about 172 degrees.